So for this one, I want to use the remainder theorem. So it means I want to divide out. X minus -2. So I'm going to put the -2 here. Oops. I'll just use synthetic division. The -2 here. And then we have 3x cubed plus 5x squared minus 6x plus 2. And so I've got 3, -6, -1. So we get a +2, we get a -4, -4 times -2 is +8, and then we get 10. So f of -2 is 10. And f of 2, okay, so I've got, bring down the 3, I get 6, 6 and 5 is 11, 11 and 2 is 22, then I get 16, 16 and 2 is 32, and then we get 34 as our answer. So f of 2 is 34. And you can check that by plugging in -2 and 2 in your calculator. But it asks you to use the remainder theorem, so we needed to do this long division thing. So given that f is that, use the remainder theorem to determine if 3 or 4 is a zero polynomial. So we can divide out a 3. So we have 2, -5, -6, and 9. So let's see. 3 times 2 is 6. 6 minus 5 is 1. That gives me a 3. -3. 3 times -3 is -9, so I get 0. So 3 is a 0. Okay, and what about 4? So I bring the 2 down. 4 times 2 is 8. I get +3. 4 times 3 is 12. 12 minus 6 is 6. 24, and I can see that's not giving me a 0. Okay. Then it says give the linear factorization of that thing given that -2 is a 0. So I'm going to start by, I'm just going to go ahead and erase some of this stuff over here. And I can do synthetic division on that. So I know that -2 is a 0, so I'm just going to go ahead and divide that out, and I should have a quadratic left over once I do that. So I have 3x cubed plus, 3, and then I have 16x squared, and then I have -5, and then I have -50. Okay, so I can drop that 3 down. 3 times -2 is -6. That gives me a 10. 10 times -2 is -20. So that gives me -25, which gives me a +50, and so I get 0. And so I can see now that the factorization that I have so far is x plus 2, and then 3x squared. (3x² plus 10x minus 25). Okay, and so then I need to factor that. X plus 2, and let's see if this factors. So if I go to 3x and x, and 25 is, let's see, I could do 5 and 5. Okay, if I do that, I'm going to get a 15 and a 5, but I want to get a 10 in the middle, so if I could do the 15 is positive and the 5 is negative, that'll give me a positive 10x in the middle. And so there it is written as a product of a linear factorization. So I'll have x plus 2, 3x minus 5, and x plus 5. Okay. Find all the zeros of that function, given that -3i is one of the zeros. And then I want to write f of x as a product of linear factors. So now I'm looking at number 15 here. And I want to find all the zeros of that function, and I know that -3i is one of the zeros. And I can tell that since this function has all the coefficients are rational, so all the coefficients are real, I know that positive 3i is also one of the zeros. So minus 3i and plus 3i both have to be zeros. And so I know that if I were to factor it out, I know that x plus 3i and x minus 3i are going to be factors. And so if I multiply those together, x plus 3i and x minus 3i, that gives me x squared plus x 3i minus x 3i, so that adds to 0, and then I'll have minus 3 times 3 times I, so it's going to be plus 9. So x squared plus 9 is one of the factors, and so I can divide that out. X squared plus 9. I want to divide that out of this quadratic, so it's x to the 4th plus x cubed minus 3x squared plus 9x minus 108. Okay, so I'm going to divide that out. And so to get x to the 4th, I can multiply by x squared. So I'm going to multiply x squared by both of those. I'll get x to the 4th. And then I have no x terms, so I'll just say plus 0x cubed. And then plus 9x squared. I want to subtract that whole thing. So I'm going to get 0 there, and I'm going to get x cubed here. And then I'll have minus 12x squared plus 9x. Okay. And then I want to multiply that by x. So x times x squared is x cubed. X times 0x is plus 0x squared. And then x times 9 is going to be plus 9x. Okay. I want to subtract all of that. So the x cubed goes away, the 9x goes away. I have negative 12x squared minus 108. And so I want to multiply this guy by negative 12. And if I do that to both of those, I'll get negative 12x squared minus 108. And I want to subtract that whole thing, so that gives me 0. And so I can see that this is multiplied by x squared plus x minus 12. And I can factor that, I think, x squared plus x minus 12. And that factors to, let's see, 3 and 4 give me 12. I want the 4 to be positive and the 3 to be negative. So those are my other two linear factors, x minus 3 and x plus 4. The next one says that I want a polynomial of degree 3 that has 2i and 5 as some of its zeros. So we know that it's going to look like this, x minus 2i and x minus 5, and it also needs another linear factor. Now it doesn't specify that the coefficients have to be real in the end, but let's just go ahead and make them real. So let's go ahead and say x plus 2i is another 0. So this one now has degree 3 because it has 3 linear factors. And if I multiply that all out, maybe I'll multiply these two together first. So I'll get x squared minus 2ix plus 2ix minus 4i squared. And then I'll have x minus 5. Okay, and then I know that I squared is negative 1. Those two add to 0, so those two are gone. So I'm going to have x squared plus 4 times x minus 5, and then I'm going to multiply this by each of those and this by each of those. And I'm going to get x squared, or x cubed, excuse me, minus 5x squared plus 4x minus 20. And that is my polynomial that I want. X cubed minus 5x squared plus 4x minus 20. Find all possible rational zeros of the polynomial function. And so what we want to do is we want to do factors of 18 divided by factors of 2. And so the list of all of those guys is going to be plus or minus 1, plus or minus 2, plus or minus 3. Let's see. Plus or minus 6. Sorry. Plus or minus 6, plus or minus 9, plus or minus 18, and then I can do all of those things divided by 2. So I can do plus or minus 1/2, plus or minus 2 halves is just 1, plus or minus 3 halves, plus or minus 6 halves, that's just 3, which I already have, plus or minus 9 halves, and then 18 halves again is 9, so I already have that. So that's all of my possible rational zeros. Now this one says find all zeros of that function, give exact values. So my possible rational zeros of this dude are going to be factors of 6 divided by factors of 1. So I'll just have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So those are all the possibles. What I'm going to do is I'm going to go ahead and graph this guy. So I graphed it, and I'm just looking at possible zeros there. And when I graphed it, it looked something like this. Kind of looked like that. So it looks like we might have a 0 here. I'm not sure. And it looks like we may have a 0 with 2 multiplicities there. So let's just check them. So if I try for 1, that is not a 0. So it looks like there's a 0 in here. There's 1. So it's in between 0 and 1. And then let's see if 2 or 3 is a 0. 2 is not a 0. 3 is a 0. And it looks like it's a 0 with multiplicity 2, possibly. Well, let's go ahead and divide out the 3 at least and see what we have left over. So if I divide out that 3 as a 0, I'll have 1, negative 7, 14, and negative 6. So I could do synthetic division. 3 times negative 4 is negative 12, and then negative 2, and I get a 6, which gives me a 0. Okay, so what I have now is x minus 3 times x squared minus 4x plus 2. And so for that, I'm just going to assume it probably won't factor because I don't have any nice whole numbers there, and I'm going to do the quadratic formula on this. So x equals positive 4 plus or minus the square root of 16 minus 4 times 2 times 1 all over 2 times 1. So what's that? 4 plus or minus square root of 8 over 2. So that is 4 plus or minus 2 square roots of 2 over 2. So that's 2 plus or minus square root of 2. So those are my other two zeros. Okay, so the answer here to number 18, the zeros are 3, 2 plus square root of 2, and 2 minus square root of 2. And so if I go back to my graph here and I plug in trace 2 minus square root of 2, I get that that is a 0. So this is checking out. So those are my zeros. Then it says write a polynomial of degree 3 with integer coefficients, and then it has those two zeros. And so I know that, I'll erase over here. So I know that it's going to have an x plus 4i, and then because it has integer coefficients, that has x minus 4i is another one. And then if a 0 is 3 halves, I could write that as 2x minus 3. So if x equals 3 halves, then I could multiply the 2 over, so I get 2x equals 3, and then subtract that. 2x minus 3 equals 0, and that gives me that factor here. Okay, so that's where that came from. So I'm going to multiply this all out. So when I multiply out x plus or minus 4i, I'm going to get x plus 16, x squared plus 16, and then I'll have times 2x minus 3, and then I'm going to multiply that out. So I'll do the x squared by each of those, and then the 16 by each of those. So if I do the x squared times 2x, I'll have 2x cubed. X squared times negative 3 is minus 3x squared. 16 times 2x is 32? 32x. And then 16 times 3 is minus 48. So that's my polynomial. So we can write f of x is equal to 2x cubed minus 3x squared plus 32x minus 48. And that has all integer coefficients. In other words, I don't want fractions. That's what I mean by integers. So that's why I didn't just write x minus 3 halves. I wrote it instead of as 2x minus 3. Okay, the next one says use the graph of that function to find the following. So the first thing I'm going to do is go over to my graphing calculator, and I'm going to graph it. So I've got 2x divided by, remember to put parentheses around the bottom when you plug it into your calculator, x minus 4. And so if I graph that dude, it looks like this. It has an asymptote, looks like at 4. I'll draw a dotted line there. And it has a horizontal asymptote at 2. And then the graph looks like this. Whoop. Okay. So let's answer these questions about it. Okay, as x goes to negative infinity, so that means I'm traveling this direction on the x-axis. What's happening to my function? My function value is getting closer to 2. And as x goes to 4 from the left, that means I'm coming in here towards 4 from the left-hand side. What is my function value doing? It's going to negative infinity. As I approach 4 from the right, that means I'm coming in towards 4 from the right-hand side. My function value is going off to infinity. And as x approaches infinity, that's going out this way, my function is getting closer and closer to 2. The domain is, well, it's defined everywhere except for at 4, and I can see that that's true because if I plug in 4, I get 0 in the denominator. So we'll do negative infinity to 4, union 4 to infinity. And on the range, possible y values, it looks like it's defined for all y values except for at 2. So we'll do the same thing, negative infinity to 2, union 2 to infinity. The vertical asymptote, so vertical, that's up and down, asymptote is the line x equals 4. And the horizontal asymptote, that's the horizon, right, is the line y equals 2. Okay. Very last one, determine the vertical asymptotes of that function. So what I'm looking for is where is this 0 on the bottom. So what I'm going to do is factor the bottom. So I have x minus 3 over, and then, so it looks like I can do 2x, and got a 5 here somewhere. So maybe if I put the 5 here and the 1 here, I'll get a 10 and a 1. I want the 9 to be negative, so I'll make the 10 negative and the 1 positive. So that gives me that. And So that means that the bottom is 0 whenever 2x plus 1 equals 0, or when x minus 5 equals 0. So when 2x minus 1 equals 0, that means x is equal to negative 1/2. And when x minus 5 equals 0, that means x equals 5. So those are my vertical asymptotes, are x equals negative 1/2 and x equals 5. So those are my two vertical asymptotes.